Okay, here we go. Oh, you're not that close. I think you were one seat up. That's where you were sitting, right, Maya? So you pretty much have the same perspective. Everybody else gets a little bit of different perspective. Now you see me up to okay. A little scary, isn't it, brother? All right. Oh, that looks fun. Quit touching my face. Stop. 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 Well, that's what I know. And stop. Because you made loud noise. I did. Stop. Stop. Okay. So I'm going to start here.
Zero, 1, 1, 2, 3, 5, 8.
Okay. Okay, these are sequences. Now, just from this, I bet some of you guys can tell me what a sequence is. Anybody doesn't have to be verbatim of the true definition? A set of numbers. That's awesome. I bet a little bit more than that, though. Set of numbers that what? Continue. Okay, that's correct as well. A little deeper. Okay, I like that. A little bit more clear. I like that though. I got what you're saying. Okay, let's see what you said. That's pretty good too. That's all I'm looking for. That's a pattern, right? How we get to the next number and the next number and the next number is because of a pattern. Okay, what's the next number after 8 on the top one? How do we get 13? We're taking the previous two numbers, if you didn't see. 1 plus 1 gives me 2. 1 plus 2 gives me 3. 2 plus 3 gives me 5. 3 plus 5 gives me 8. 5 plus 8 gives me 13. 21. That's just the start. Technically, this has a name. Does anybody know what the name of this is? Who said it? Right somewhere here. Fibonacci.
Yeah, that's it.
Fibonacci.
It's a matrix.
Okay, sounds like Italian. I don't know.
This is the sequence that was almost
Okay.
a bunch of things. You know,
Awesome. The Fibonacci sequence is actually about mating the bunny. One bunny plus one bunny gives you 2 bunnies. If you add another bunny, you get some more bunnies. There it is. Hello, Deb. I don't even get a hi? That's better. Thank you. Feel bad. Okay, next one. What's happening here? Let's talk about the pattern. Let's not shout out things. Just raise a hand that's still there. Anybody? Oh, Dave, hold on. Chuck. Is that very quick?
Next number is the last term minus 3.
Last term minus 3. Do you guys agree? What's the next term of our sequence? Negative 11. 14. Oh my God. Negative 17 and so on. Correct? Any questions there? As Chuck just said, he used the previous term and found the pattern of subtracting 3 every time. This has a specific name. I'll talk about it in just a moment. Okay, the next one. What's our pattern? Grease, can you see it? Yeah, multiply by 3. What's 81 times 3? 243. Multiply by 3, 729, so on. But we have a pattern, didn't we? This also has meaning to it. Not a specific one, but in type in general. Isn't subtracting the same number as the same thing as adding the same number as well? Because what could I say if I wanted to say adding? Or adding -3 is the same thing as subtracting 3. Would you guys agree? Okay. Adding -3 is the same thing as subtracting 3. Okay. So this is actually called an arithmetic. Okay, arithmetic is when we consistently add the same number over and over and over. Does anybody can remember what we could associate this with? Something we've already previously learned. Go ahead.
I want to say a linear graph.
A linear equation. Notice if I'm adding something consistently, isn't that a constant slope? Okay. Anybody okay with that? You might want to write that in your notes. That's actually pretty good. Arithmetic is similar to a linear equation. A geometric, that's what the next one is. What's its generalized rule to make it geometric? Again? Timesing by the same number? Is division the same thing as multiplication? Isn't division just timesing by a reciprocal? If I'm dividing by 3, isn't the same thing as timesing by a third? So understand if I see something dividing, it's still geometric. Geometric means that I am multiplying by the same number over and over and over. Okay? We will actually be studying the bottom two. Not necessarily today. Today we're doing the arithmetic. Okay, so we're going to study that, and then next time we're going to study geometric, and then on Monday we do the binomial theorem. Okay? So you're going to play with a lot of those fun ideas. Everybody listening on that? Any questions on that? Okay, done. We talked about tests today after school. You're the only one in here that hasn't taken it, correct? Cool. All right, so let's start with a arithmetic equation. Give me a number to start with, Miss Quinny. You said, I heard you won't even drive with your mama. You said you won't even drive with her. I talked to your mama about you. I said, she's like, how's she doing? I said, she won't drive with me. Is that going too far to the talk to your mama? No. Yes. Okay, that continuous I to do comma dot 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 that goes on forever. Forever and ever, amen. The song. All right. So, I could continue to get this. Notice, what term would this represent? Term 1. This is our first term. What's this represent? Second, third, fourth, fifth, sixth. Okay? Specific term. What if I wanted you guys to find a sub 48, which means the 48th term? Can I do that?
Yeah.
How can I do that easier than just I don't want to keep doing that. I wish I had kids on the test. But it took forever. I'm like, that was only worth 2 points. Okay, you know what I mean? So there could be an easier way to do it, right? Yes, sir.
Put it into a linear equation and plug it up.
Hence by the association. Yeah? What is the linear equation that we've learned in the past? Mx plus b, some people use ax plus b. Where did you learn that? New York? Huh? Who? Where did you learn ax plus b? There. There. She uses a? Interesting. I thought you said Gary. I'm like, that's my dad. You learned it from my dad or Mr. Twitcho?
Good old
Yeah, I'm an
Gary.
SOG, guys. I'm son of Gary. I'm an SOK as well. Son of Gary. Together.
How do Robert?
No one's a beast, okay?
Wait, what's your first name?
Or so guy.
My mother,
No, what's your
my first name, Lane.
Blaine?
Blaine something. DJ
I don't go
Roberts.
by Blaine.
Oh, you know Blaine?
DJ.
There, yes, my grandfather's name is Blaine.
That's because you know.
No Blaine Ballard here.
Yeah.
He's actually the only kid in my whole life that I've seen Blaine with spelled the same way as me.
How's it sound?
Blain.
Oh, no.
They usually put the E on it.
You're,
But mine's a no E. I don't know why, but that's how it is. That's how my grandfather had it. But I was never called Blaine a day in my life until I went to my first year of teaching. I could go by Blaine. And I walked down the hall, and Blaine. And I was like, what's going on? And then they're like, Blaine. I'm like, oh, yeah, that's me. I'm like, yeah. It just didn't work. No.
what you go by? You go by what?
There was even a funny story one time. There's a lot of athletics. Anybody play athletics right now? Anybody doing athletics when they were younger? Okay, don't they call you by your last name a lot, especially in athletics. So one time I was playing, and they're like, Robert, get your bell here. So I run over there. I said, what are you doing here? And I'm like, tell me, coach. And he's like, you're not Robert, you're me. Get the hell out of here. I'm like, sorry, sir, he was calling myself. That cousin? Which cousin? I got many. I don't ever played any foot fetish game with a cousin of mine. Soccer. Those people that have a foot fetish. Our feet the whole time. That makes sense. Silly people. Love you all. Anyway, let's do math. We have time today to do talk. Y equals mx plus b. What does the m represent? Slope. A. That represents slope, right? What does the b represent? Y-intercept. We don't call it slope and y-intercept here because it's not technically rapid. Instead of slope, we say common difference, which is b. What is our common difference? What's happening? How is 4 getting to 9? How is 9 getting 14? We're adding 5, right? So our common difference is 5. It could be, it's related to it, but it's not necessary. It could be. It could be.
You could put it on.
I'm not necessarily doing it. Okay? That's a lot of stickers on this. What's your favorite one? The unicorn? Very true. Always be yourself, unless you suck. Okay. What's another name for our y-intercept? The zero term. Wow.
Starting term.
Because notice, this represents the first term. What would represent our zero term?
-1.
Because I would just go, notice I'm adding 5, so therefore if I went backwards, I am subtracting 5, that's how I got to the -1.
So what?
Well, that's a whole different one. We're only talking about arithmetic.
We're not talking about Fibonacci now.
There is a lot of there's an infinite amount of sequences in the world, and there's an infinite amount of arithmetic and an infinite amount of geometric, but there's an infinite amount more of those as well. There's so many out there. Because I could have a pattern where I'm doing this every time. Oops.
No, that's 9.
The negative amount, so you're multiplying it by -1.
I mean, this is a sequence, but it's neither geometric or arithmetic. So there's lots of sequences out there that don't have to be arithmetic and geometric. Yeah, we're like the Fibonacci. Answer your question for you? So we're only studying what today? Arithmetic. Okay. So with that being the case, I want a sub 48. Well, let's find a sub n. A sub n, because we don't use x, we represent n. N represents which term I'm looking for. A sub n is, what is my common difference? 5 times n. What was my y-intercept slash 0 term? Negative 1. So this represents an explicit formula. Now I'll write that down. It's an explicit. EX explicit. How do you spell that, guys? EX explicit. EX. Sure. I'm not sure if I'm right. Explicit. That's why I start scribbling when I don't know how to spell. Okay. Explicit.
I just write it and I'm like,
So,
does that look
this
right?
is the one I was looking for, though. This is a tool to help me to get where I want, right? Right now, it looks like why you only have one arm. Put his arm back. You know how some people have one arm? You would how they have the nub on the end. That's what it looks like. I had a friend in 7th grade, and then he moved somewhere. I don't know where he moved to. But he used to always say, "It wasn't me. There was a 2-armed bandit." So he had one arm. And there used to be, it wasn't me, it was the 1-armed bandit. So he used to be 2 arms. No. And then supposedly, I guess he went to Lone Peak. I didn't know that. But his senior friend was a guy on a motorcycle and rode it through. And they're like, "How'd you know it was me?" "Well, there's not too many 1-armed people for our school." Pretty Ethan's not even carried. Ethan, I'll swear for you. No? Not even a giggle? I'm not mocking him. He's a really good guy. He could open up a carton of milk with his little nose. I don't know how to A sub 48, not, it's just skills that I could never have, because you don't have that. Anyway, 48. 5 times 48 minus 1. So we have 240 minus 1, which is, so the 48th term is 230. How do I know it's given you the first time? We'll usually say it, or you have to understand that it is. So yeah, right. So right there, guys, we have to find any term given the sequence already started. That's probably the easiest one where I can go back one step to find my 0 term. I can see my common difference. I write my equation, plug it, chug it, plug it, right? That's pretty good. Notice the other kind we could have is I'm telling you it's an arithmetic sequence. Now you guys are going to help me out. Give me a number, any number.
1,700,000.
Not listen to him. What? 40. I'll take that.
Yay. Well,
No, Maya. Oh, yes. That's what we're going to say unless it dictates otherwise. Say, give me another number. All right, 8. I heard her first. Sorry. Okay, so this time I'm telling you it's an arithmetic sequence. Okay. So therefore, what does that mean? Why is that important? Because it does dictate this could be anything. This could be any sequence, right? So therefore, it's an arithmetic. So therefore, it does have a common difference. If you guys will recall, you used to find a common difference. What's another common difference? What did I replace it with? You know, slope. Okay. You used to be able to find slope between how many points? How many points did you have to find the slope between? Isn't that basically 2 points? Okay, how is this as a point if you think about it? I have the 4th term, my result is 40. Right? I have the 8th term, it is 8. See what I did there?
Yep.
Any questions on that? Nope. Okay, how can I find slope? Give me another name for slope that you guys used to say. M. Awesome. A. Great. Love it. What else? Rate of change.
right, so around.
Rise over run. Okay, how many of you guys have taken chemistry before or physics? Most of you, right? Have you guys ever seen this? Delta means the change of y over the change of x's, which is the rate of change. Okay? Rise over run. Isn't that the difference of our y's, or our change of our y's over our change of our x's? Does that make sense to everybody? Okay. Now there's a couple ways to do this process. Well, first off, I just need to find the slope. Okay. So the fact of the matter, because then I can see how it's gauged, how much it's going up by every. Let's go ahead and do so. So the change of my y. Now it doesn't matter who I start with as long as I keep it consistent, right? I'm going to start with 8. 8 minus 40 would be the change of my y. So can I go 4 minus 8? I need to go 8 minus 4, don't I? If I did him first, I got to do him first. Is everybody with me on that? Any questions so far? What do we get here? Negative 32 over 4, which is negative 8. That's my common difference. Now, could I go backwards and keep saying, okay, well, what would be a sub 3? 48. A sub 2? 56. And so on, right? I can keep going back. So what if I gave you a sub 100 and a sub 200? Are you guys going to go back 100 times? No, so it doesn't make sense, does it? Maybe here it would. Okay. So, but what do I know? If you guys recall, there was 2 ways that I could still write an equation. I was always taught by doing point slope, which is very similar to what I'm going to write right here. A sub n equals a sub 1 plus my common difference of n minus 1. And the reason where this comes from, ladies and gentlemen, is if you can remember point slope when you did the equation, but not every teacher uses it. Okay, that's point slope. That is what you were taught. Find the slope, put in a point. That's what x1, y1 means. But notice, guys, if I add y1 over, nah, y equals y1 plus slope times n minus 7. What's our first value of x1? Remember, if this is a1, what does this always have to be? It has to be 1. If this was a4, what would this value be? 4, because it's a point. x1, y1, x1, y1 is the point. And remember, on the point, it's saying, what term is it and what value did I get, right? So what term was the 4th term? You knew it, it's up here a little bit, what was it?
It was
40?
Yeah, 40.
So isn't that a point?
Yep.
So I could plug, oh, this is a sub 40. So let's write this out. A sub 40 equals a sub 1. I don't know what it is. Do you guys know what it is? Unless I went backwards with my slope, right? Once again, that's not always the case that you want to go with. So a sub 1 plus, what was my difference? We did find that out to be negative 8, parentheses, n minus, instead of 1, I'm going to do 4 because it's the 4th term. Notice that 4, that 4 and that n, because those n's kind of almost represent the same thing. Okay. Nope, this is still minus 1. I apologize. I messed that up. That's still 1. I'm about to put in 40 in just a minute. Yes, ma'am.
What's that?
M. As in Mary. I talked to your aunt this weekend. I don't know what the hell her name is. I just know she's in this neighborhood. In Lee. I don't know. I know she has a daughter on her religious sabbatical at 18 months.
Yeah.
Maddie.
Yeah.
It was on the news.
Mm-hmm.
So what did this n get changed with 40 there? So what does this n need to be changed with? 40. What is a sub 40 though? What the hell am I doing? I messed this up. Can we just have a restart? Because that was just hell. Let's start again. Rewind. Ready? I am looking for the fourth term because that's what I know. The fourth term equals a sub 1 plus our difference, which is still negative 8, n minus 1. But once again, because I replaced this n with 4, what should I replace this n with? Does that make more sense, ladies and gentlemen? I apologize. You feel okay?
No.
No? Well, you got a unicorn. You should. Guess what I watched the other day? You guys, maybe you've never seen it, but in my childhood, it was something that was seen a lot. The never-ending story.
I love that movie.
It's really messed the hell up. I watched it again. I'm like, how did I like it?
I don't know. I watched it
That
like a kid.
crazy dog dragon.
Yeah.
And then my daughter started crying when the horse died. The never-ending story.
My family owns the first two movies.
It's on Netflix right now. Check it out. You might have to now understand it was made in 1980.
It is very weird. It just felt normal to me because I watched it when I was young.
I watched it when I was young. It was great too. Okay, what is a sub 4? We know it. Yes, hi. No sorriness. This thing, it just points float. We don't care about it. I'm just trying to show you how it relates to this.
Oh, someone did that.
Okay, what's a sub 4? We know what that is. What was it? 40 equals a sub 1 plus, or excuse me, negative, whoa, shiznit, whoa, this is 3. So that's negative 24.
Do it.
I did math, people. 4 minus 1 is 3. 3 times negative 8 is 24. Keep up. Right? Right, Emma? How do I get a sub 1 by himself? Add 24 over, so a sub 1 is 64. Did I want to find what a sub 1 was? Was that my goal? What was my goal? To find a sub... Did I ask you guys to find anything? Oh, damn it. Darn it. Please find a sub 22. Whoa. I went 4 minus 1. 3 times negative 8 is... You did not keep up.
I did not.
All right. Keep telling. Tell him. You got to keep up. Warfare in here, man. So now, guys, I just come back to my original equation. A sub n equals, do I know my a sub 1 now? What is he? 64. Plus, do I know my difference? Still negative 8, but n minus 1. What term am I looking for now? What term in general, because I have my generalized term, what am I looking for? 22.
Oh, we were looking.
A sub 22 equals 64 plus negative 8, 22 minus 1. Hi, Chuck. Chuck, look, you never have to pass a paper again for a while. Because you're not sitting in front.
Wait,
Isn't that nice? That would be correct. Who sat there in the first place? Oh, Dave did. Okay, so we got 22 minus 1, which is 21. 21, so that's negative 168. 64 minus 168 is negative 104. That would represent the 22nd term. Does that make sense to be negative 104? Let's take a look at it. The fourth term is 40. The eighth term, 8. So yeah, it keeps on getting lower and lower, right? That makes sense. Okay, can I show you a different way? Yes, no? Okay, here we go. Yes, ma'am. One? 8 of 8? Because that helps us find the slope. Because I could plug in instead of 8 of 4 as I did down here. I could plug 8 of 8 in. As long as you have 2 points, what do 2 points allows us to find what? The common difference or the slope. That's the key part. That's why I had to have 2. Okay, so I'm gonna do this the same way. We already know my common difference is -8, correct? Now I do know my a sub 1, but let's pretend we didn't find that. Okay, let's go back to the original. Oh, I found my common difference. And a sub 4 is 40. A sub 8 is 8. Okay? Once again, I still want to find a sub 22. How many of you guys did not learn point slope form? Which I would say not half of you. They probably said, only equation you ever need to know is y equals mx plus b. You can do everything off of that. Anybody? Yeah? Okay. Did I do good without the voice? Was it a higher voice or a lower voice? You can do anything with this y-equals lower? Higher than? Oh, lower. He's like, so, right here what he's got. Okay, we're done. Okay, well, I can find this as well, ladies and gentlemen. Do I know my common difference? What is my common difference? What does x and y represent? They represent a point, don't they? Do we have a point? We do. Right there. Right there.
Whoa.
This time I'm going to use the point 8, 8 instead of 4, 40. So I'm going to say, oh, golly, 2 shoes. 8 equals -8 times 8 plus b. That's -64. Because 8 was x. If you want me to use this one just for different numbers, I can show you. We'll go over here on the side. Y equals -8 times x plus b. So that's 40 equals -8 times 4 plus b. Which is -32, which is 64. How do I get rid of 64? Add in. So b is 72. Add in. What do I get? As it should be, right? So what's my generalized equation?
Y equals
We don't want to do y's though. We want to do a sub n equals -8n plus 72. And we're looking for term number 22, correct? You with me, Ray? Okay, so we're going to put in 22. So that's negative 178. What did we get the first time? 104? That multiply. Oh, that's a skip. Times table. And then negative 176 minus plus 72 is. The math is kicking. Kick apple. Well, just do that right now. There's a lot of apples in the ground. Do you have an apple tree? Maybe have an apple tree. What kind of apple?
I don't know. I just really have 4
Huh?
of them.
Fuji? You have one? You what? Mr. Roberts wants to try a Fuji apple from your tree. May I try one next time?
Mine are babies, so they don't produce any real apples.
Bullshit, isn't it? Second year they'll produce an apple, just bend off
Well,
the
yeah,
end.
but they're like really tiny.
You get big ones, you just gotta learn how to love
They
and grow
stop out
them.
with being elected.
You're not a very good apple farmer.
No. We only have 4 of them.
That's not a real apple.
Yeah.
My mama's got 1, 2, 3, 4, 5, 6 apples.
My grandma.
Huh?
I don't have 10 fruit trees.
Nice. It's not your mama. Yeah. So, whoop, hey, hold up, hip, hop.
Here we go.
Let's say that was explicit. An explicit formula can allow us to find any term at any point. Like one being, I could find a sub 1, I could find a sub 100 if I wanted, right? I can find a sub 4072, right? Those are all possibilities as soon as I get my explicit formula, correct? Do you guys agree with that?
4,000.
But there's another way to do it. That was the explicit way. You guys have learned this in the past when you were in secondary 1, is the recursive. So if anybody remembers what recursive is, it's more in this form.
Oh, that one.
What does this even mean? A sub n equals a sub n minus 1 plus b. Well, we all know what the b is. That's the difference. But what does the a sub n minus 1 represent? Right? The difference. That's exactly what this is saying. A lot of people get confused about what this is. And as Quinn just said, I think she said it very, very nice, is it's the previous term. Because let's just figure it out. Let's say, first off, anytime you do a recursive, they either have to give you 1 or 2 of values that are consecutive. Usually they'll give you a sub 1. Let's say a sub 1 is 2. And my common difference is negative 3. Does that make sense to everybody? They'll have to give you that, or they'll have to give you a sub 1 and a sub 2 and tell you it's arithmetic so you can find the common difference. With me? Okay. I would like us to write the first 5 terms. So we're going to do it via recursive. So a sub 1 is easy. It was given, it's 2. But what's a sub 2? So let's put Quinn's use to what her definition to use. So Quinn said a sub n minus 1 is just the previous term. So what's the previous term to a sub 2? A sub 1. Does everybody understand why it's a sub 1? That would be the previous term to a sub 2. Doesn't that also make sense? Because notice, what is n representing? 2. Right? What's 2 minus 1? Hence the previous term. Right? Plus our difference, so what's our difference? Negative 3. Right? We're substituting stuff in. What is a sub 1? It's 2. 2 plus a negative 3 is negative 1. Or a sub 2 is negative 1. Everybody there with me? Yep. He is. Looking around, Ian, Tanisha good back there? A sub 3. How do we find a sub 3? Well, a sub 3 is the previous term plus a negative 3, right? What was a sub 2? Negative 1 minus 3 is? How do we find a sub 4? Our previous term minus 3, which is negative 7. A sub 5. Our previous term minus 3 is negative 3. See how recursive works? But notice there's limitation on a recursive because I have to know the previous term to move on. So could I find a sub 48? Sure. But I gotta do. I prefer not to do this. Okay? Does everybody see how it's just taking the previous term and subtracting the previous term? Okay. Any questions there? Right. So, now my next question to you guys is this. Okay, what's the difference? What's the top one called? It's an arithmetic sequence. It is a sequence, though. Okay, the one below it, isn't that a sequence? 1, 3, 5, 7, 9. But there's addition in between, right? It is still the same numbers as above. Okay, I agree. This is a sequence that you are adding together, which is called a series. So does it have a pattern to it?
Yeah.
Yeah, so therefore it is a sequence, and this we call a series. And a series is just the sum of a specific sequence. Now notice, guys, we have two different types of sequences. We have one that stops, right? This is called a finite sequence because it stops. What do you guys think the other one's called? It just goes dot, dot, dot. Infinite. Or so. Infinite, infinite. Okay, infinite one. Could I really find the sum of an infinite series? No. Because there's no stopping point, it just keeps going and going and going and going to infinity. Right? Does that make sense? You could actually do it with a geometric. That's pretty cool. But let's bring out the sum. What's the sum of this? 25, really simple to add, right? Okay, I'm going to give you guys a little history of math lesson. Back in the day, I don't know when it was, but his name is Gauss. Anybody heard of Gauss? Gauss was a Kool-Aid mathematician. How many of you guys believe you're as smart as Gauss? I believe a lot of you are. Okay? If you ever think about it, why don't we ever find these theories? Well, first off, it's given to us and we just take it for granted, right? But as somebody said, how do I become one of these people? How could I find these theories? What if you never came to school and you were serious? You think you'd ever be one of those people? Depends on where you're at, right? But he wanted to be an educated man. He was going to his teacher. Maybe his teacher was having a rough day. And his teacher was like, "Hello, children." In the German / French / European accent, because I don't know what he's talking. And he goes, "Children, I would like you to add the numbers of 1 through 100 together and tell me the sum." Let's see if you guys are as smart as that. The teacher thought, oh, that's going to take an hour, maybe a half hour to an hour. He got done in a minute or two. Okay, so what did he do? Let's think about it. Now, if you already know this, don't raise your hand and jump off of his his plan. So that's cool thing to think. I've already had every class in here supposedly figure it out. So Gauss wrote out numbers 1 through 100. Maybe it took him a little bit more time because that takes a while, right? And then he found out the sum. Anybody have an idea? Have you learned this before? All right. Have a theory. Go.
And then, like, 298 and 100. You can do that with every number in between until you get to 50. And there's just that 50, which is like the middle number.
Okay.
And then you have that 100 at the end.
So how many of these pairs will I have? Okay.
And then you have, and so 48 times 100 plus 50 plus 100 is 50, 100.
You're very close, but off just a little bit. Okay? Technically, there's 49 pairs. Okay? So I have 49 pairs times by 100. So then I already have another 100. Plus, as you said, the middle number, which was 50. What does that have to be? 50. Okay? Could have been your theorem. But, slightly different, because one I'm going to go off, I'm going to go just slightly different. What's 100 plus 1? Because I don't want to have to do this every time. What's 99 plus 2? What's 98 plus 3? What's 97 plus 4? What's 96 plus 5? How many 101s do I have? 50. Because I have 100 numbers and I'm grouping them into pairs. So wouldn't that mean I have 50 pairs? Right? 50 times 101, what's that in your calculator?
50/50.
Okay, so, pretty cool, huh? Now, once again, why am I telling you that story as well? So you guys can connect it, because I'm gonna make you guys memorize this formula. Right? So there's actually a story to help you remember. So, once again, let's write our formula. So, notice we've been finding a specific term, we write a sub n, but I'm finding the sum of a number of terms. The sum of a number of terms. How did we find the sum? Tell us our process. What was technically the process last that I did? Not to say that hers wasn't right. It came out, but it had a lot more work than mine. Did you guys agree? Yeah. What did I do to get my 101?
Putting them pairs.
Putting in the pairs. What pairs did I add up first?
The bottom and the top.
The first term and the last term. Because I don't know how many terms there are every time, but I know I have a beginning. I should call this my beginning term. Because what if I wanted the sum starting at the 10th term to the 100th term? Then I'd start at a sub 10, wouldn't I? Does that make sense? So I should call that the beginning. What is a sub n? The last term. Did you guys agree with that? Yeah. That's how we got our 101. It's just 1 plus 100, right? You guys agree? How did we get 50? So we took the number of terms, which we had 100, right? And divided it by 2.
Touches everything.
Don't touch stuff that isn't yours. True? Is it yours or mine? Did you buy them?
No. It's underneath the backpack.
Ladies and gentlemen, this is something you're going to need to know. Okay. So, but the story helps us find it. That's exactly what we did. So the first term adds to the last term. So the number of terms divided by 2. So let's go back to our original one that I had up on the board. Wasn't that the odd? 1, 3, 7. Hi, Sarge! Where are you parking today so I can parallel? You going anywhere today since you need the car? I have a test to do. Okay, so we had 1, 3, 5, 7, 9. Guys, let's just check out what we have here. What is that as to me? Ooh, he's not a pair this time. But he's directly half of the amount that they added up. So whatever your middle number is, so if there's odd enough terms, your middle term will always be the half number of what they add up to be. Does that make sense to you? So, but let's look over here. How many terms did we have? 5 terms. So we're finding the S of 5. Is everybody with me there? Equals number of terms. 5 divided by 2. Who's our first term? Plus 9. That just works. What's 1 plus 9? 10. 5 halves of 10 is 5 times 5, which is... Now, I'm not saying if I only had 5 terms, would I really use this formula? Probably not, right? It would probably just add them up. But it's showing that this formula will always get to be this. Pretty cool, huh? The Bella's kick A. Did you not? What day are you leaving me again for your surgery? Oh, so we're golden. 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 All right, calculator time. We're good. Right it is. Who has GIA 3 right now? You do? You do? Awesome. You guys can't follow me in person. We'll hit you up though. Yeah, 84. That's that. Cool. That's mostly the who has that other one? I don't know how to use that. Beware. Yep. CRCI. Somewhat, let's figure it out. I might be able to get it. I was working on it earlier. Okay. All right, here we go. Calculator! Yeah! 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 I gotta go back to this though because I forgot to start what the hell we're talking about. Yeah! The sum!
What?
The sigma. Here, maybe that's right. So you can, Emma's like, what the hell? I heard it in her mouth and it didn't come out. Does it ever come out that way, Emma? Be swear. It's okay. You ever say, paper knockers? My wife said, oh, ducks and puddles. Is that better? Okay, that's a sigma. You guys have probably seen it on a frat house. Sigma Chi. I don't know. You get what I'm saying, right? Okay? They use the Greek letters. So whenever you guys see those sigma, you don't think of a frat house. You think of sum.
Some crowd.
Okay? You're going to think of a sum. All right. Or water. Okay. So here. By the way, this was 1, 3, 5, 7, 9. Let's see if we can translate this stuff into this equation. What does the 1 mean? What term we start on? That's on the first term. What does the 5 mean? We end on the 5th term. Yes? What does 2nx minus 1 mean? That's the equation. Notice we're increasing by 2 every time. Does everybody see that? Hence the slope. If I wanted to go back to my y-intercept or my 0 term, just cut back 2. Negative 1. Does everybody understand how I can find this stuff from a sequence? Yeah. To the machine! You guys get excited about going to the machine ever? To the machine! We'll get you, brother. We'll hook you up. And you. Okay, here we go. Ready, set, alpha. Alpha! Alpha. F2, which is your window button. Alpha F2, unless you have CI 3 or 6. Okay, I'm not trying to make you feel bad. I just hate that thing. It's actually a great calculator. I just don't know how to use it. You guys see it? How many of you guys had the lovely window pop up? Let's put it this way. Who in an 84 did not have a window pop up? Really? Every 84 had a window pop up? Guess what? I don't have to update it. Dancing. Sorry, Dan. Will that embarrass you? Connor, just do hip shakes, brother. Fly right into that. That's how I got my wife. Not saying you guys, maybe you do, I don't know. Yeah, that is. My goal. Isn't that not my goal every time? It's covered on one side. You guys need to take pictures so I can put it on the wall and everything, because I've been working on this for a long time. Okay, so what are we going to be doing? We're going to do the summation, which is the second one. I apologize. I didn't look. Okay, let me see how we have this pop up. You guys wish, and I'll help you. What? Yeah, but mine's fun. Okay, what are we going to do? X equal to 1 to what number? 5. What was our equation? 2x minus 1 super x. And then I go, Jesus. Isn't that the sum of 1, 3, 7? It does. Good for you. How the hell did they put that on? But I don't know. That's cool though. Isn't that the sum that we've already found? It's just a different style. For everybody, everybody's going to do this with me, but if you have a TI-84, you never have to do this again, but I want you guys to do it. Okay, for TI-83, here we go. TI-83, are you ready? You're going to hit second. List, where it says step. Then I push over to math. Which one am I going to find? The sum. Sum of what? What do I want to find? The sum of a sequence, right? Sum of a sequence. So I go second stat again underneath the list. So this time I go to the OPS and find the number 5. Now, mine popped up a window because mine's TI-84. How many of you guys TI-84 has popped up a window? Yeah. So what you're going to do, give me 1 second, Chica and Chico. Okay, I'm just going to hit enter through this and I'm going to show you what I want you to do. The sequence.
On the 5.
Okay, so this is what more you guys have, correct? It came right through here, is that correct? Correct, Ms. Maya? Okay, here's what you're going to do. All right, that's what you have. That's what you're looking at right now. So the first thing you put in is the equation that you're using. What was my equation that I was using? 2x minus 1, comma's right next to the parentheses. What variable is going to be replaced by? X, comma. What number did I start with? 1, that's the first term, not 1 because that's the first number of the sequence, 1 because that's the first term. Yes? Yes, people? Okay. Comma, what term did I end on? The 5th term. Now, you could also put in how often or what increment it goes on, but I don't have to, so I'm just going to close that up in here. The X just says what variable is in your equation. Okay, so that's what you're going to have to do. Okay, here we go. Now notice, on your test, are you just going to be able to just plug it into your calculator? You silly rabbit. Okay, so what if I give you this? The sum from x starting at 3 to 45 for this term of 4x minus 3. What is the sum? Everybody plug and chug with your machine. With the machine at first, and then we're going to go backwards. Do it the other way. Well, oh! Did you stain it today? Now you got to stain it though. Not like you're not going to put a stain on? No, that's cool, so why not put a nice lock or liquor or whatever the heck it's called? That's really cool. Lacquer.
Is that what you got?
It was alpha F2. Alpha F2 is able to where you go, right? Yes. An alpha F2?
Yeah, I just put that and do it.
Awesome. About the same. I would say they're the same. It's okay. All right. So, ladies and gentlemen, what did we get? 3,000. That? Oh.
Hmm.
My TI-83ers? You got it? Let's see where you're at. My 86er? I'll help you in a moment. We start at 3.
Oh, no, that's right.
3.
Okay.
That's the first term is 3. Comma. 45. Comma. I mean, print. Good. So let's do this mathematically. Okay, by the formula. How many terms are there? I see how you think 45, but notice we started at 1. We started at 3. 42? Did 3? Yeah? No? Not? 43. How did I get 43? I know how you guys got 42. How many of you guys want this minus this? Yeah. Notice, guys, how many terms was 1 to 5? 5 terms. Notice 1, 2, 3, 4, 5. How many numbers are between 0 and 10? 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Subtract, add 1. Notice, subtract and add 1, that gives me a 5, right? Subtract, add 1. You might want to write that down to tell you the real number of terms, because you will see this in another day, maybe next class. I'm a freak, yeah. You ever hear people freaking? Super freaking. Hey, your mathematical skills got told today that they're excellent. Just by your name, they're like, oh, Lincoln kid, he's a really smarty. Just let you know, you got high standards now. Okay, so how many terms do I really have? 43 terms. So I'm going to find the sum of 43 terms. So how many terms am I using? 43 over 2. Because remember, the number of terms divided by 2. Hi, sir. Josh. Oh, is that now in our box? A new one? You don't want it. I saw like 6 in my car. Yeah. That was last time. Ooh, nice. 3 Wendy's and Arby's again?
Yeah.
I like that Pollo Loco, actually. Actually, not too bad. Okay, what is, remember in our equation it said a sub 1, but what did I tell you is a better definition? The beginning term. Who's our beginning term? 3. So do I put 3 here? No. I want to figure out what is the third term of this sequence. How do I find that? By plugging it in. 4 times 3. 12. 12 minus 3. 9 would represent my third term, correct? If you think about it really quick, this would be my 0 term would be negative 3, because remember that's your y intercept. So who would be your first term? 1. Second term would be, I'm adding 4, so that's 5. Third term is 9. You see where I'm getting this from? But notice, basically all you gotta do is plug that number in, and I'll tell you the third term, which is our beginning term, right? So that's the bottom. What's our last term? 45, so I plug 45 in. 4 times 45. 180 minus 3. So that is 188 times by 43rd halves, which is 94 times 43. What's 94 times 43? Somebody. Did I mess that up? Really? 43 times 94? What did you say it was? Did I mess something up? Did I add wrong? That sucks. That's the first time I'm wrong today. Well, the 177 came by plugging 45 in. 4 times 45 is 180. 180 minus 3 is 177. What's 9 plus 177? Oh, Dingleberry. Dingleberry. Not 188. I'm a silly rabbit. It's a 186er. Gosh, banger, crackers. Can somebody do 43 times 90 for you? Do we have to use our machine to do it for us? No, the formula can do it. Now, the key thing about the formula, ladies and gentlemen, is how did I receive this 9?
Unknowing your
Plug this in, and I have my explicit formula. So this is the third term. Plug it in. 12 times 3 is, 4 times 3 is 12. 12 minus 3 is 9. How did I find 177? My last term, I plugged them in. 45 times 4 is 180 minus 3 is 177. Yep. And I still got the same result, right? Okay, your homework's on math itself tonight, and the next night, and the next night, and the rest of the day for this. And that's 93 came from 186. I just didn't want to go 43 times 186 and then divide by 2. I just divided by 2. Thanks for question, Kelso. Thank you, Kelso.